Hello, welcome to the video. In this lesson, we're going to be looking at section 8.1, where we're going to be defining and using sequences and series. So, I guess one of the first things that we need to kind of look at is what exactly is a sequence and what is a series. So if you look at the definition of a sequence is an order of list of numbers. Now, uh, these lists could be either addition, subtraction, multiplication, and division. So that's how these sequences kind of go, or a series of multiplication and division, multiplication and addition, stuff like that. So when we are given a sequence or if we are given a rule, we can figure out what values are going to be from either the sequence rule that's given to us or the sequence of values in order for us to create a rule. A series, on the other hand, is terms that are added together. All right. So you could have a bunch of sequences and then you would find the sums of those things. So first off, um, looking at, again, this is a sequence, and usually what happens is when you are given a sequence is you have whatever value it is determined by the spot in the sequence. So like the first number in the sequence, they call that A1. Second number of the sequence is A2, A3, A4, all the way up to however many values there are in a sequence. If you look here, they talk about either a finite sequence or an infinite sequence. If you have a finite sequence, there's an actual stopping point, and if you notice, there's nothing else after it. But in an infinite sequence, they have like those two, or I'm sorry, the three dots, and that just means it keeps going on and on until infinity. So, first thing is we are going to be given a rule, and in this case, we have a rule right here, which is 2n plus 5. They want us to find the first 6 terms of this. So what I would like you to do is kind of like what they did in the directions is rewrite the 6 terms as A1, A2, A3, A4, A5, and A6. So all you're going to do is you're going to replace whatever n is with the number in the sequence. So since the first one is 1, so it's going to be equal to 2 times 1, because that's my new value of n, plus 5. When I do all the math in order of operation, a sub 1 is going to be 7. When I go to the second one, it's going to be 2 times 2 plus 5. That'll be equal to 9. Here I got 2 times 3 plus 5. That's going to be equal to 11. With a sub 4, I got 2 times 4 plus 5. That is going to be equal to 13. Here I got 2 times 5 plus 5. That's going to be equal to 15. And then finally 2 times 6 plus 5 is going to be equal to 17. You can kind of even see a pattern here with the values in the sequence. 7, 9, 11, 13, 15, 17. They all add up by twos. So you can say like the next one will probably be 19, 21, so on and so forth. Looking at part B, again, just go a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. Here I get negative 3, and then since n is going to be to the n minus 1 power, that's going to be to the 0 power, this is going to be 1. Here I get negative 3 to the 2 minus 1, so that's 1. That's going to be a negative 3. Here I got negative 3 to the 3 minus 1, which is 2. This is going to give me a positive 9. This is going to be negative 3 to the third power. I get a negative 27. Here I get negative 3 to the 5 minus 1, which is now 4. This is going to be a positive 81. And I get negative 3 raised to the what looks like fifth power, and that will be, because it's odd, it's going to be negative 243. So if you notice, in the sequence, you have one positive, one negative, one positive, one negative. Anytime you kind of see that pattern involved, you're more than likely your value of n is part of the exponent. And so that's kind of a little tip when you're going to be asked to write a rule. Okay, so here it's asking you to describe the pattern, write the next term, and write a rule for the nth term of the sequence. Okay, so basically what I really want you to do is tell me what the next term is and then write the rule. Okay, really what I really would like you to figure out. So first off, looking at example A, we have numbers in the sequence of -1, -8, -27, and -64. What I like to do sometimes is to see if there is a common difference. Common difference means is you take the two uh, consecutive values in the sequence and subtract them and see if there's a pattern. So if I took -8 and I minus it by -1, I would get a -7. Problem is -27 minus a -8 doesn't get me -7. It gets me -19. So uh, it's not quite uh, what I was looking for when it comes for a common difference. But what I do notice is that the values of 1, 8, 27, and 64 are all perfect cube numbers. So what leads me to believe is you are going to be using something that is raised to the third power. Okay. Now, because it's negative, I believe that there's going to be a negative uh, portion of this value. And since this is like my a sub 1, this is my a sub 2, this is my a sub 3, I believe it's going to be negative n to the third power. So that is going to be my rule, negative n to the third power. What I would like you to do is make sure that it is in fact consistent with what you wrote down. So if I put -2, raise it to the third power, I get -8. If I went -3, raise that to the third power, I get -27. -4, raise that to the third power, I get 64. So I am consistent throughout the entire sequence of values that were given to us. So I'm led to believe that the next value, or the next term, is going to be -5 raised to the third power, which is going to be -125. Okay. For part B, if you notice here, if you look at a common difference, if I took 2 and subtracted by 0, I get 2. If I put 6 and subtracted by 2, I'd get 4. If I got 12 and subtracted it by 6, I get 6. There is sort of a pattern there, which means that I'm led to believe that the next value of difference will be 8, because I'm getting 2, 4, 6. I believe it's going to be 8. So my belief is the next term in this sequence is going to be 12 plus 8, which is 20. All right. Now, what we have to do is we have to be able to write a rule. Okay. Now, anytime that you get a pattern with respect to the common difference like we have here, you have to take into account that you're probably going to be using your values of like a sub 1, a sub 2, a sub 3, a sub 4. You're going to use n in a way that you're like multiplying two numbers or multiplying at least two terms with that value of n. All right. And so if I look at this here, so if I looked at anything a sub 1 is going to give me 0. So I have to figure out that how to get one of my terms to be 0. So thinking about this, like let's say I put n and I subtracted it by 1 because 1 minus 1 would give me 0. And let's just say I just multiplied it by n. So for the first one, 1 minus 0 is 0. 0 times 1 is 0. That checks out. Let's look at the second one. If I put 2 here, 2 minus 1 is 1 and n is 2, so 2 times 1 is 2. That checks out. If I go 3 here, 3 minus 1 is 2, and 2 times 3 is 6. That checks out. Uh, for 4, 4 minus 1 is 3. 3 times 4 is 12. Still works out. And then finally, we said it was 20. Um, 5 minus 1 is 4. 4 times 5 is 20. All right, so I did find a rule for every term in the sequence. Okay, again, this is very, very similar to what we did before. Again, if you have additional questions, uh, let's take a look at number 4. So if you look here, and I try to do a common difference, this is 2, this is 2, and this is 2. All right, so what we have here is we have a common difference of every single value being the same number. So here they ask you to graph the first 5 terms. Well, at least if I wrote the next term in here, so if this one's going to be 2, that means it's going to be 11. And if I put 2 here, this one's going to be 13. So anytime you have every single value is the same number in those common difference, you're looking at a like a linear um, equation or a linear rule. Okay, so basically you're using like y, equals mx plus b to help you solve it, so to speak. So, but they use n, so that that makes things a little bit different, but not too bad. So basically, what you're going to do is, well, I would almost go here and say, look at a common difference of 2, so that would be 1. So essentially, your y-intercept is going to be 1 because this is essentially like a sub 0 when you look at it in here, because this is your a sub 1, this is your a sub 2, this is your a sub 3, this is your a sub 4. So with that, that means I have 1 is my y-intercept, so whatever it is going to be multiplied by 1. So what do I have to do to n to make it look like 3? So I put n right here. To make it look like 3, I'd have to multiply it by 2. So 2 times 1 plus 1 should give me 3. Looking at the second one, 2 times 2 is 4. 4 plus 1 is 5. 2 times 3 is 6. Add that 1, at 7. 2 times 4 is 8. 8 plus 1 is 9. Yeah, so this is my rule. All right, a lot of it is being able to, excuse me, kind of guess and check a little bit. But again, if you do have additional questions and trying to discover what those rules are, please let me know. I'm more than happy to look at those. So the next thing that we're going to be looking at is the series. Like I said, the series is when you take a sequence and you add those values together. All right. So when you look at a series, one of the things that we are going to be asked to try to identify and maybe even write a rule is being able to write things in what is called sigma notation. So this is an example of what sigma notation is. All right, sigma notation is you're using the Greek letter sigma. Kind of looks like an E or a sideways M. But what we have to do is this. Here, this right here is the rule of a sequence. Okay, so whatever the pattern is. Okay, and then on the bottom, right here where it says I equals, here they use, in series, they use I instead of N. It is what it is. That value, that is what you're going to start with. So in here, they start with I equals 1. And then the top number here, which is 4, that is when your series is going to stop. So in this case here, it's 2I, so you start with 1, 2 times 1 is 2. That's where the 2 comes from. Then you go to the next one. 2 times 2 is 4. That's where they get 4 from. 2 times 3 is 6. That's where they get 6 from. And then 2 times 4 is 8. All right? And because they have the 4 right here, that stops. If you have a infinite series, like here, it's going to infinity. It just has the dot, 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 and it keeps going on and on forever. Okay. So what we are going to be asked to do here is we are going to be asked to look at a series and write it using sigma notation. So I have my sigma notation. Okay. All right. Looking at the values, just pretend like this is a sequence. Just think of it as like 25, 50, 75, and it keeps going, and then eventually it goes to 250. Okay. So there's a stopping point because there's no dots after 250. So it's a finite series. Looking at this, so like this is like my 1, this is my 2, this is my 3. All right. If you notice, all those seem to be um, values that you could multiply to get from 25. So what I'm going to do is I'm going to write this as 25I. All right, I'm going to start with I equals 1 on the bottom. And then what I'm going to do to figure out what my top value is I'm going to take the 250 and divide it by 25. 250 divided by 25 is 10. So I'm going to put 10 over here. All right, let's see if it works out. So if I put 25 times 1 is 25. 25 times 2 is 50. That checks out. 25 times 3 is 75. And then the 25 times 10 is 250. So this would be my series written in sigma notation. Okay. If I looked at B, I have 1/2, 2/3, 3/4, 4/5. Okay. What I notice when when I look at this pattern is like this is like my 1, this is my 2, this is my 3, this is my 4. All right. If you notice, every single value in the numerator is the value in a sequence. So what I believe is I am going to put n, or I'm sorry, it's not n anymore, it's I. So I'm going to put I over here, and it's going to be divided by, and it looks like if you look at the denominator, it's just added 1 from whatever the value of I is. So I'm just going to put it as I plus 1. I'm going to start with I equals 1 on the bottom. And since it keeps going on forever and ever, my top number is going to be infinity. So this is my series using sigma notation. Okay. Again, takes a lot of practice, but after a while, it's something that um, you should you should get really familiar with. Um, it is quite useful in being able to discover what those values are, especially for sigma notation. So I think, again, these are kind of similar to what we just did. Again, if you're unsure, leave me a comment. I'm more than happy to work those out. Finally, here they're asking you to find the sum. Okay, so what we're going to do here is they want you to start with 4, so it's going to be 3 plus 4 squared plus 3 plus 5 squared plus 3 plus 6 squared plus 3 plus 7 squared plus 3 plus 8 squared. All right, since it started with 8, or had 8 on the top, I stopped there. So looking at the first value, I get what? 16 plus 3 is 19, so that's 19 plus 25 plus 3 is what? 28 plus 36 plus 3 is 39 plus 49 plus 3 is 52 plus 64 plus 3 is 67. So I just add them together. 19 plus 28 plus 39 plus 52 plus 67, and we get a sum of 205. And that is being able to define and use sequences in series. Hope this helps. Till next time.